This video, Sine Application Part B, completes the second half of the Sine Application problem that I started in the video called Sine Application Part A on my YouTube channel. Now, I'll give a brief recap of where we left off. Here's the problem. You go out to a dock. After you have been there for 4 hours, the water is at low tide, which is a depth of 5 feet. After an additional 6 hours, the water is at high tide, which has a depth of 35 feet. Write a sine equation expressing the depth of water in terms of time. So, in the previous video, we created this graph to model this situation. Now, we can use this graph to make the sine equation that this problem wants us to find. To form this graph into an equation, I need to find these pieces of information. First, let's find the period. The period is the distance it takes to complete one full cycle of the function. So far, we have only graphed one period. If we were to graph more than one period, we would see the graph repeat itself. So, if we look at the one cycle of this function, we see that the period is from 1 to 13. So, if we subtract 13 minus 1, we find that the period is equal to 12. Now that we have found the period, we can find k. 2 pi over k is equal to the period. So, if we plug the period in, we get 2 pi over k is equal to 12. And now we can solve for k. So, if we solve for k, we find that k is equal to pi over 6. Now, let's find the phase shift. The phase shift is the horizontal shift from the parent function. Our function has moved to the right one, so our phase shift is right 1. Now, let's find the amplitude of our function. The amplitude is the height from the midline of our function, and the midline is just the line right down the middle of the function. So it is the height from the midline of our function to the maximum. So from the midline to the maximum. You could also say that the amplitude is from the minimum to the midline, whichever you prefer. But if we subtract 35 minus 20, we find that the amplitude is 15. And now, let's find the vertical shift of the midline of the function from the parent function. Our function has moved up 20 vertically, so we can say that our vertical shift is up 20. Now that we have found all these pieces, we can write our sine equation. The format of a sine equation is this. Where b is k, d is the phase shift, a is the amplitude, and c is the vertical shift. So now we can just plug our numbers into the equation. One thing to note is that our function has been reflected over the x-axis compared to a typical sine function, which looks something like this, where it would go up first and then come back down. So our function will start with a negative to show this x-axis reflection. So here's our negative, and then we can just plug in the rest of the numbers. And you can go ahead and multiply this out a little if you'd like, and you get y is equal to negative 15 sine of pi over 6 x minus pi over 6 plus 20. And now we are done, because we have found a sine equation that models this situation in this problem, expressing the depth of water in terms of time. If you found this video helpful, please go ahead and hit the like button. And also, please subscribe to my channel if you haven't already. And as always, thanks for watching.